All right, quick reminder lesson on Euler's theorem or Euler's method. So Euler's method, you're going to be given a differential equation. You're going to be given an initial value, and you'll be given what you want to go up by your change in x, and you're going to try to evaluate some point, one value at a given x value. So I just made up a problem. Here's my differential equation. I'm given that y1 is 2. We're going to go up by 0.1, and we need to evaluate what y of 1.5 is. Okay, starting at 1, we're going to go to 1.5. Now, Euler's method is used when you can't separate variables. So here, we can't divide by y to move it to the other side because we're adding x and y. So there is no way to separate the variables here. So the only way to actually approximate y of 1.5 would be to use Euler's method. As long as the distance isn't too far from 1 to 1.5, we're okay. All right, so the way I would do it is I'd make an xy table. My first x is 1, my first y is 2. We're going up by 0.1. Okay, so we're trying to figure out what that is right there. That's our answer. Going from 1 comma 2 to 1.5 comma something. So what it is, the formula is to find the next y value. You take the current y value and you plug your current x and y value into your differential equation. So this is not dy dx times this, it's dy dx of x0, y0, and then times dx. So to find out what we know, y of 1 is 2. So what is y of 1.1? Well, that's equal to y of 1 plus dy dx of x sub 1 comma y sub 1 times dx. All right, our y sub 1 is 2. If I plug in our x and y into our differential equation, all you're doing is adding your x and y. So 1 plus 2 is 3. And times dx, it's always going to be 0.1 in this problem. So 2 plus 3 times 0.1, so 2 plus 0.3 would be 2.3. So now to find my next one, so my y sub 1.2, you take your y sub 1.1, which is 2.3, plus we're going to plug in our current x and y into our differential equation. Well, all I'm doing is adding them, so 3.4 times our dx, which is 0.1. So 2.3 plus 0.34 is 2.64. Find my y sub 1.3. We take my y sub 1.2. Plug in our current x and y into our differential equation. So that's 3.84 times 0.1. So add those together, 3.024. This is when it'd be nice to like fast forward through all this. I'm not tech savvy enough to do that. So my current y value plus, if I plug them in, I did just do this problem, so I've got the numbers written out here. So 3.4564, and then what we're looking for and I get 3.94204. So y sub 1.5 equals 3.94204. It's an approximation. All right. That would be Euler's, not Euler's method.